Lesson 7 and 8 is going to be parameter changes involving parallel and perpendicular lines. We, we learned some rules about this from the Algebra 1 book on page 132. What we learned was that parallel lines have equal slopes and never intersect, which we already know, but we're really specifically worried about the fact that they have equal slopes. And then perpendicular lines have inverse, from the word additive inverse, reciprocal slopes, multiplicative inverse. So they have inverse reciprocal slopes. The inverse part means change the sign. The reciprocal part means flip it over. So if we wanted to apply that, let's say that we had the number 2/3 and we wanted its inverse reciprocal. The inverse says change the sign to negative, and the reciprocal part is telling us to flip it to 3/2. So the inverse reciprocal of 2/3 is negative 3/2. You understand that? What is the inverse reciprocal of negative 5? Well, you'd think of it as negative 5/1. The inverse part says change the sign to positive, and the reciprocal part says flip it over. So the inverse reciprocal of negative 5 is positive 1/5. Understand how to find inverse reciprocals. Now, if you go into your Algebra 1 book now to page 135 to 136, you will find what we call the old new drill. Yes, I did. 135 to 136, thank you. Then you're going to find what we called the old new drill, and then this is how we did it. So, question number 1. What we're wanting to do is write the equation of a new line. Our goal is to come up with the equation of the new line, and we're just using some organizational skills to get there, okay? It says that our new line is parallel to the old line. So here's my old one. And what I want to do first of all is identify the slope and y-intercept of the old one. So what is the slope of the old one? 3. What is the y-intercept of the old one? 4. And then we're going to go to the new one. It says the new one has a y-intercept of 6. That's kind of hard to miss. And then we're going to think about the concept of parallel or perpendicular, whichever one they gave us, to determine what the new slope is based on the old slope in those rules up there, right? So it says that they are parallel, and we know that parallel lines have equal slopes. So if the slope of the old one was 3, then the slope of the new one is 3. They're parallel, so the slopes are the same. I've got what I need to write an equation, so the equation of the new line is y equal slope 3 times x plus y-intercept 6. But say we got number 1. So we taught you the old new drill just so you were organized. I can see my old slope. I've got it written down. I'm going to think about parallel. You may not have to go through all that in pre-cal like we did in Algebra 1, but it doesn't hurt to be organized. Okay? It doesn't hurt. Any questions on number 1? Number 2. Number 2, it says the new line. So again, we're trying to write an equation for the new line. That's our job here. Which means we need the new line's y-intercept and we need the new line's slope. And we're going to use the old line's information and the idea of parallel and perpendicular to come up with the new stuff. Now, it says perpendicular. When it says perpendicular, then as far as the slope is concerned, we know that the slopes are going to be what? Inverse reciprocals. because perpendicular lines have inverse reciprocal slopes. As far as the old one is concerned, what was the old one's y-intercept? 6. What was the old one's slope? 4/5. Everybody understand so far? Now it says that the new one passes through the point 0, 3, negative 3. What's that? It's y when x equal 0. And what is that the definition of? The y-intercept. The y-intercept is the value of y when x is 0. So that's just another way of telling you what the y-intercept is. On the new one, it's a negative 3. Y when x is 0. I can say the y-intercept is this, or I can give it to you as an ordered pair. Now, the old slope was 4/5, and I need the inverse reciprocal. So the inverse part tells me to do what? Change the sign to a negative. It was a positive 4/5. The inverse part of that inverse reciprocal phrase means change the sign. The reciprocal part says flip the 4/5 over to 5/4. Okay? Inverse, change the sign, flip it over. Reciprocal. So my new equation is y equal, my new slope, negative 4/5, x, and then my y-intercept minus 3. Any questions on number 2? Okay? Very good so far. Now, this says that the new line, I want to write an equation of the new line, is parallel to y equal 4. Now, every time we get to this x only, y only stuff, we have to kind of go off the grid, right? It all works different because there's some memory work. And the place that I kept telling you in Algebra 1 to go to is page 104 at the top right, because that's our memory work for horizontal and vertical, right? We said an equation that's y only is an equation that's y only is a horizontal line. Now we're talking about the old one, y equal 4. What is the slope of every single horizontal line? 0. And the y-intercept on a horizontal line is that constant y value 4. So I look at that and go, ooh, that's a horizontal line. And since it's horizontal, the slope is 0, and the y-intercept is the constant y. And then it says, well, it's parallel to that. So then I would think, see, I'm not messing around in here now because we're away from that parallel and perpendicular rules, because that doesn't apply to horizontal vertical. It could, but it's all weird, right? I'll talk about that in a minute. So we need to think, what kind of a line is parallel to a horizontal line? Another horizontal line. So my new line is going to be another horizontal line if it's parallel to a horizontal line. And what kind of an equation does a horizontal line have? A y-only equation. So my new equation is a y-only equation because it's the equation of a horizontal line, because it's parallel to a horizontal line. And if it's a horizontal line, what's its slope? 0. And its y-intercept is going to be whatever that constant y is. Now it says that this line, and that's this green line here, has a point on it that is 3, 7. That's the y of that point. That means that that must be a horizontal line that goes through y is 7. If it has one y of 7, they're all 7, because that's the constant y value. Everybody still, we got number 3. Okay? And you could say, well, they're parallel, so they have equal slopes. The first one was 0, second one was 0, so we could have used that. That's still true. All right, number 4. The new line, again, we want to write the equation of the new line. That's our job. It says perpendicular, so we're thinking inverse reciprocal slopes. But then it gives us what kind of line? It gives us a horizontal line because it's a y only. This is my old one. My old one is y only. It's horizontal. And what is the slope of every single horizontal line? 0. And the y-intercept on a horizontal line is that constant y value 3. So we're saying, okay, I started out with a horizontal line, and it says perpendicular. What kind of a line is perpendicular to a horizontal? A vertical. So I know that my new line must be a vertical line if it's perpendicular to a horizontal line. What kind of equation does a vertical line have? An x only. What is the slope of every single vertical line? Undefined. And what about the y-intercept of a vertical line? Well, let's just consider that there was an xy axis somewhere. A vertical line doesn't cross the y-axis. It's parallel to the y-axis. So for y-intercept, we put none because it doesn't have one. It's parallel to the y-axis, you see. Now, it says that the new line has a point on it that is 7, 3. To the right 7 up 3. And the equation of a vertical line is x only. It's x equal to constant x. And if one point on that line had an x of 7, that must be what the x of every single point on the line is. So the equation is x equal that constant x of 7. Understand that? Now let's talk about this inverse reciprocal thing. Perpendicular lines have inverse reciprocal slopes. Hello. Okay, so where does the 0 come from? How do you get a 0 for an answer? 0 divided by any number will give you 0 for an answer, right? What is the inverse reciprocal of that? Negative some number over 0. Do I agree with that? Division by 0 is mathematically undefined. So what is the mathematical reciprocal of 0? Undefined. What's the mathematical reciprocal of undefined? 0. We're going to need that in trigonometry second semester, okay? So we could have applied that, or we could just jump to the horizontal vertical rules, either way, okay? But there is a mathematical reciprocal of 0, and there is a mathematical reciprocal of undefined, okay? All right, now number 5, it says my new line, and I want to write an equation for that new line. But I'm going to use my old line stuff to get it. What is the slope of my old line? Just looking. You can't find it just looking because it is in standard form. So the first thing I'm going to have to do is to go from standard form to what? Slope-intercept form. So to go from standard to slope-intercept, my first move is to get that x on the other side, remembering to change the sign when you cross over. And so we're going to have 5y equal negative 3x plus 20. Understand that? Now we're going to undo multiplication by division. Good. We're going to divide 5. We're going to remember to distribute our division, right? And And so we're going to have y equal negative 3 divide 5x plus 20 divided 5 is 4. So there's our old line written in slope-intercept form. So my old y-intercept is 4. My old slope is negative 3/5. And then I can head to the new. It says the new line passes through the point 0, 2. That is the value of y when x is 0, which is the y-intercept. So the y-intercept is 2. It said perpendicular, and I know that perpendicular has inverse reciprocal slopes. The inverse part means to change the sign from negative to positive. The reciprocal part says flip it over so it becomes a positive 5/3 for slope. Understand that? So my new equation is y equals slope 5/3 x plus y-intercept 2. Any questions on the front side of the 7-8 worksheet dealing with parameter changes involving parallel and perpendicular lines? Okay? Pretty good. All right. Number 6. The new line is parallel to this point and passes through the point here. We're not going to run the old new drill this time. We're just going to try to work our way through it. Now, first of all, if we're going to write an equation of the new line, what two things would we really like to find? Our slope and our y-intercept. Now, it's parallel, so the slope is the same as the slope of that one, but we don't know the slope of that one because that one is written in some weird form that looks like standard form, kind of, sort of. Some textbooks call that general form. Some still call it standard form. It's just not in slope-intercept form, so we need to get it in slope-intercept form. To get it in slope-intercept form, we're going to move the 20 to the other side. That kind of moves it to what we're used to, standard form. And then we're going to move the x to the other side, which we could have done at the same time. And now we're going to undo our multiplication by division. Distribute that division. We get negative 3/4 x minus, divide with different signs, is negative 5. It says that they are parallel, so my line has the same slope as this line. So my line's slope is negative 3/4. But I need the y-intercept. Now, it didn't say the y-intercept is blah. And it did not give me the value of y when x is 0. So how am I going to get my y-intercept? Well, I'm going to use my slope-intercept formula, right? I'm going to pick a point and the slope, and I'm going to plug them into the point slope or the slope intercept formula or point slope formula and transform it. I like this method better. Other teachers like the point slope form better. We're going to take the y of the point and plug it in place of y, the slope, and plug it in place of m for slope, the x, and plug it in place of x, and there's only one variable left, b, and b represents a y-intercept. So we used a formula with y-intercept in it to try to find what we were looking for, the y-intercept. And so we're going to have 3 is equal to, 2 goes into 4 twice. We get negative 3 over 2, which is negative 1 1/2. Is everybody good with that? Plus b. You can leave it improper if you want. We're going to get rid of subtraction by addition, so we're going to add 1 1/2 to both sides. And so we have the y-intercept is 4 1/2. So now I can write my equation. My new line is y equals slope negative 3/4 x plus the y-intercept of 4 1/2, which we could have written as 9/2, correct? Any questions on number 6? Parameter changes involving parallel and perpendicular lines. Okay. Any questions? Very good. Okay. Number 7. Now, what we just did was less than 7. This last problem is less than 8. And the question that I have to ask you is, what does that right there mean? Well, the answer I heard was absolute value. This right here represents absolute value, correct? But that's not what that looks like. It's got this on it also. And that's not absolute value. That is the greatest integer function. It's the greatest integer function. So we need to talk about the greatest integer function. We probably need to write some of this down. Now, let's just do a little bit of review. Y equal x is the parent function of a line. Y equal x squared is the parent function of a quadratic. We could just keep talking about parent functions. Okay? Y equal is the greatest integer parent function. And the way the greatest integer works is it's the greatest integer in the number without going over. You ever watched Price is Right, that show? And you guess, and whoever guesses the closest wins without going over. You can't go over. If you go over, you messed up. You're out. Okay? So you want to get as close as you can without going over. You want the greatest integer in it without going over. So let's just play with some numbers just to see if we understand what this is saying. What is the answer to that? The greatest integer of 2.3. You know what integers are? Positive and negative whole numbers. Negative 3, negative 2, negative 1, 0, 1, 2, 3. What's the biggest integer in that without going over? 2. If you went to 3, you went over. If you went to 1, there's one bigger than that. So we're going to think about this. Okay, we've got the integer 1, the integer 2, the integer 3. What's the greatest integer that's in that without going over the number itself? 2. Okay? That makes sense? Now, let's think about this. I'll let you catch up. Let's go to the other side of the number line. Let's say we had the greatest integer in negative 2.3. Now we're thinking this. We're thinking negative 3, negative 2, negative 1. Are you with me? Because we're on the other side of 0. Now, what is the greatest integer in negative 2.3 without going over? Where's negative 2.3 at? It's in there. Negative 2 is bigger than it is. If we're not going to go over, if we're not going to get bigger, we're at negative 3. Negative 2 is bigger. So it's the greatest integer in it without going over it. You see what happens when you get to the other side of 0? It gets a little tricky. Okay. Now, let's start thinking about this. What's the greatest integer of 2? 2. What's the greatest integer of 2.1? 2. What's the greatest integer of 2.7? 2. What's the greatest integer of 3? Now, if you were to graph that, then we would have to the right 2 up 2, to the right 2.1 up 2, to the right 2.2 up 2, to the right 2.3 up 2, to the right 2.7 up 2, and then when we got to 3, we would say to the right 3 up 3, to the right 3.1 up 3, 3, 3, 3, 3. You see what's going to happen? Now, was the 2 included in the red part? Yes, it's going to be colored in. Was the 3 included in it? Nope. The 3 is in the next little piece. 3, 3.1, 3.2, 3. When you get to 4, what happens? It's not included here, but it's going to be included there, right? So what we're going to have is a bunch of these little guys. It's called a piecewise function or a step function. It's the greatest integer function, okay? Everybody kind of getting the idea of what's going on? Okay. Now, I'm going to go to the graphing calculator now just to make sure we have this concept down. Let me pull it up. I should have already had it up. It's hiding back here. All right, and we need to be able to punch that in the calculator. I'm going to minimize that. So we can do our calculator second plus 7, 1, 2, enter, clear. We're going to go to y equal. We want to put this equation into our calculator. Now, we need to do greatest integer. So we're going to go to math, and we're going to go over to number, and number 5 is integer. We went math. We add to the right to number. We're going to choose number 5, which is integer, and we're going to put x. So we're asking it to graph the parent function of the greatest integer function, okay? And we're going to hit graph, and we can see that it's those steps that we talked about. Now, there's a little mark right in here. 0 is going to be open on this one, so it jump to 0. When you go to 0.1, what's the greatest integer of 0.1? 0. 1 is bigger. What's the greatest integer of 0.5? 0. What's the greatest integer of 0.9? 0. What's the greatest integer of 1? You see where it jumped? What's the greatest integer of 2? Here. So what you've got to realize is, on this end, it's a closed circle, and on the other end, it's an open circle, right? Because the 2 ended up there, okay? Closed circle on the left, open circle on the right, okay? Now, what would happen to the parent function of a line if you were to add 1, shift up 1, remember all those parent function transformations? What's going to happen if I take that and I put, let's just look what's going to happen. If I go back to my greatest integer math number 5 integer, and I'm going to put, did it say x plus 2 in there? X plus 1? Now, let's think about that. Remember, did you do this in Algebra 2? What's outside the parenthesis happens to y according to the order of operations. And what's inside the parenthesis happens to x in the reverse order of operations. You remember hearing that? Well, let me help you out a little bit. Let's remember when we had y equal a times x minus h quantity square plus k, graphing form of a quadratic. And this thing out here is going to happen to what? Y. The way you see it. If that's a plus 5, it's going to shift up 5. It's going to shift in the y direction with what you see, plus 5. But what about this number in here? It's going to shift in the x direction, the opposite of what you see. Remember that? So if you see a minus h, it's going to shift in the x direction plus h. Now this is really cool. This happens according to the order of operations. When it's happening to y, it happens according to doing. If you see a plus k, it's a plus k. How does it happen to x? According to undoing, what would undo a minus h? Plus h. So inside the parenthesis, what happens, it's happening to x according to undoing. So this plus 1 is happening to x, and it should be happening to x according to undoing. So all of our x's should be 1 less than they used to be. And if all of the x's are 1 less than they used to be, what's going to happen to the whole graph? X is 1 less. X gets less to the left. The entire thing should shift to the left 1. Okay? So this should go left 1, left 1, left 1, left 1, left 1. The whole thing is going to shift. In the reverse order of operations, according to the x, because it was inside the parenthesis. So if we hit graph, we hope that happens. You see? The whole thing shifted left 1. Everything you ever learn in math connects to something else in math. If you learn what happens to a quadratic in the parentheses and outside the parentheses, it happens to every other kind of graph. Because it's all based on order of operations. Okay? All right. Now, when you do that particular question on the test, you will get to use a graphing calculator and kind of see. But you do need to know that you're going to have a colored in dot here and an open dot there, and you really need to know why. Okay? All right. One more question. What is the greatest integer of negative 0.6? How do you think that out in your mind? Well, you think about the number line. When you think about the number line, you got a 0, and you got a negative 1, and you got a negative 2. And where is the negative 0.6? It's right in there. I missed a little bit. Now, you got to have the biggest thing in it without going over. So what's the biggest thing, closest thing to it without going over? Negative 1. See how that works? Closest thing without going over. It's like Price is Right. Okay? All right. Any questions on greatest integer function? All right. That's lesson 7 and 8. And if you need to see some of that again, you can just watch